Uniform acceleration means that you're going in a straight line at constant rate of changing velocity. So whether you're speeding up or slowing down, uniform acceleration just means you're going straight and your object's either speeding up or slowing down at a uniform rate. Right? Non-uniform acceleration would be like if you're coming up to a stop sign, you hit the gas or brake to slow down a little bit, and then you realize you're not stopping fast enough, so you press it harder. Right? So your instantaneous acceleration would change, but your average acceleration would be the whole braking period from start to finish. Does that make sense? Any other checks for these terms? If I can use them now, and you guys will be okay. We have to be on the same page. Ethan?
Just displacement versus distance again, just because I want to make sure that I really get that through, because I got confused on that last year.
So on this graph, or these pictures here, if we want to go to McDonald's for lunch today, here are 9 different routes that we could take to go to McDonald's today on Highland. We can go by, I want to have hiking here. And I'm not sure why hiking and biking are different routes. Because in this one, they're going through Monarch Woods, and here we don't. We stick to the roads and driving. Right? So you can see, probably not actually, because the font's really small. Okay? I had to fit it up here. But each route covers a different distance, and they have different times, right? 6.1, 6.4K. If we bike, it's 3.4, 4.3, 4.3, 4. So they're all different distances, right, to get from here to McDonald's, and that does not include the elevation changes that it takes to get there either, right? Because as the bird flies is a lot faster than as you walk, because you have to go up and down. So when you're looking at those, all of those are different distances traveled, but the displacements are all the same, right? All our displacements are from our classroom here at Res to McDonald's over here. Does that make sense? Yeah, that makes sense too? I don't know if you guys have been to Algonquin Park and gone hiking there. There's a trail there that I did in my mid-20s. It was, it's called like the Centennial Trail. It's like 10K. And my friends and I, we were like pretty excited to go on it. And then what they didn't tell you on the map is that you have to go up and down the mountains there like 5 or 6 times. So not only do we do like 10 linear like K as the bird flies, but we change elevation, 6 or 7 times going up and down these steep cliffs and mountains. So we actually covered a much greater distance than the 10K. So it was a large workout. Took us a lot longer. And we didn't have water, so we were a little dehydrated and delirious at the end. So that was just poor planning on our part. But when we talk about, going back to this, right, we talk about displacement and distance, average velocity, average speed. I want to drill this in your head, is that average velocity is not the same as average speed with the direction at the end. A lot of people say that. If I ask that on a test, I get that like 75% of the time. That's not true. Neither is displacement is distance with the direction on the end. That's also not true in all cases. There's the only case those two statements are true is if you're doing the 100-meter dash, where all your displacement and distance are in the same direction, straight line from start to finish. Then your distance and displacement are the same. As soon as you do like a 200-meter sprint and you hit that corner, then your distance and displacement are not the same anymore, and the displacement is not the distance with just a direction at the end. Okay, if you look at the maps up here, right? The displacement for all of these is the exact same, and I don't know the compass heading, so I can't tell you what it is, right? But each of these distances are different. And then the displacement for each of the three pictures is the same, whatever it is in meters and direction, but the distances are different and the numbers you're going to say are not the same. So if I do ever ask you on a test, you know, what is the difference between average speed and average velocity, I won't give you a lot of marks if you just say it's average velocity, it's just average speed with the distance. Right? One's based on displacement, which is a straight line from point A to point B, and distance is based on the route you take to get there. Right? It's the same thing if I said, you know, let's go to the Tim Hortons right now or to go down the CAP. Right? We'd all leave the room. Some people might go down the stairs over here, some might go down the floating stairs, some might go down over there. And it was the CAP, we'd all race down there, but we might take different routes. So all our distances would be different, but your displacements would be the same. Does that make sense? Your project, the project for this unit, part of it, one of the options is a sport-based event, or sorry, an Olympic event. So it's sport-based, and a lot of races are based on not the displacement, because all the racers have the same displacement from the starting line to the finish line, but the distance they travel, right? And the shortest distance win. So if you're in like a ski race, right? A ski race, I'm sure you guys seen racers on TV, right? They always try to find the best line to get from the top of the hill to the bottom of the hill. And that line is based on the shortest distance from the top to the bottom. They all go through the same gates going down, if it's slalom skiing, but the shorter line, the shorter distance gets the skiers down to the bottom faster. And you could be talking inches different, but it's something that makes the better athletes better. All right. So Andre, back to your question. Oh, sorry, before we get to the equations, there's 6 of them, as you guys know from last year. They're not any different. Are there any questions with any of the terms? My test questions, I have a few, I don't think today, but probably tomorrow, that are based not on your defining the terms, because like grade 11. All your knowledge questions are how you use the terms. So make sure that you understand them not by memorizing their definitions, because that doesn't get you anywhere. You have to understand what they mean. There are 6 equations that go on this page. Any takers as to what they are? Make Ms. Silva proud and show that you remember from last year. Without cheating on your formula page. Andre?
BF squared equals BI squared plus 2 something.
Yeah, good. Plus 2 what?
Oh, I have a different one.
Oh, anybody want to finish, Andre? Any guesses?
Is it 2A
Almost.
or 2AD?
2AD. Yep, good. I'm going to do the acceleration equations just in this column here. So these are the accelerations. So our first one, and there I just put 1 because it's the first one we named. Okay, so they're all vectors, so they all get the half arrow on top. We have VF squared equals VI squared plus 2A delta D. Okay? Are we okay with each of those terms up there, or do you want me to define them? You guys are okay with VF, VI, A, and D? Any takers? Okay, remember that they have to be in our standard units now, so everything's in meters, meters per second, and meters per second squared. No more kilometers per hour or centimeters per second, all that stuff. All right, second equation.
D equals VF minus VI over 2 times delta T. I think that's 1.
It is 1, yeah. Do you say minus or plus?
Minus.
Plus. Almost. But it's like the average.
Right.
Sorry, not like it is the average. Okay, so that equation is one of the kinematic ones, right? Does not have the word acceleration in it or variable of acceleration, but it has the other one. 2 down. We don't have the easiest one up there. So I'm proud of you guys. Yep. Olivia? Oh, it's VF squared equals VI squared plus 2A delta D. No problem. Yeah.
A equals V2 minus V1 over delta T.
Yeah, good. Okay, so number 3 on our list is VF minus VI over delta T. Okay, that's usually where you start acceleration. Not the easiest one that goes on the board there, but that's probably number 2. 4 and 5 in that list are related to each other. One of them will become your favorite equation because it's the one that we're going to use the most. Anybody remember them? And we don't have the uniform motion equation up here either. That's the easiest one. Any takers? Alex?
Isn't an easy one V equals D over T?
Yep, good. So uniform motion, you can have average velocity, which is delta D, your displacement over time, or the speed version, which is the same, just with distance. Remember, displacement has an arrow on top, distance does not, but they look the same with delta D, the change in.
Wouldn't the second equation be speed, not velocity?
Second one's speed, yeah. That's that?
No, you got me. I just
Yeah, this one's average speed, and that one's average velocity because they have the arrow on top. All right, number 4 on our list. I'm gonna call this one 6 because this is like the end. 4 is delta D equals VI times delta T plus 1/2 a delta T squared. So this is a quadratic equation based around delta T. It has an a squared plus b, or an ax squared, a bx term, and a c term. So we'll be using a quadratic formula of that one tomorrow, not today, I don't think. And then the last one is number 5. Just looks similar to the one above, but it uses VF this time. So you have delta V or delta D equals VF delta T minus 1/2 a delta T squared. That equation, I don't remember the last time I used it. So it's there, it's an option, but I honestly don't remember the last time I used it.
It's like 4 or 5 in grade 11.
Oh yeah. I just do 2.
I used 2 in 3rd. That was all I used in grade 11.
So I want you guys to also, when you're looking at these, right, make sure you know the variables, obviously. If you need me to define any of them, I will. The second thing is when you do your questions that you always use the numbers that are given to you in the question. Oftentimes I see 1 or 2 students who will take a question and go a really long way to solve it because they only like certain equations. So they might always start with this one because they like this equation, but I'm asking for displacement. They do this one to find, like, say, time and then substitute it in somewhere else in a different equation. So they do 2 steps instead of 1 that would be easier to do. It's always a little weird to me, but I get it because everybody thinks differently. So just when you guys are doing your homework, always make your table of values and make sure you pick the right equation that gets you through the question efficiently. You don't lose marks for taking the long way. It's just you run out of time on a test because you only have a finite amount of